Greetings, guys. This is finding missing angles with trig ratios. So what we're going to learn to do is we're going to learn to find missing angles with trig ratios. That's the topic of today's assignment. Okay? And we can use trig ratios to find missing sides of triangles. We're actually going to talk more about that when I see y'all. Missing sides of right triangles. But when we're finding missing angles, we're actually going to use inverse trig ratios. We can use inverse trig ratios to find missing angles of right triangles. So that's what we're looking at today. So remember, you've got three trig ratios: the sine, the cosine, and the tangent. And we've learned that the sine of an angle is equal to the opposite of our hypotenuse. The cosine of an angle is equal to the adjacent of our hypotenuse. The tangent of an angle equals opposite over adjacent. These three trig ratios with the -1, sine -1, cosine -1, tangent -1, these are inverse. The -1 makes inverses. Okay, we call this inverse sine, inverse cosine, inverse tangent. And see, what happens is the inverse sine reverses this. In other words, if the sine of the angle equals the opposite of our hypotenuse, the inverse sine of the opposite of our hypotenuse equals the angle. See how it's just switched these? So if I want to know a missing angle, I can take the inverse sine of that ratio. If the cosine of the angle equals the adjacent leg over the hypotenuse, then the inverse cosine of the adjacent leg over the hypotenuse is equal to the angle. If the tangent of the angle is equal to opposite over adjacent, then the inverse tangent of the opposite over the adjacent is the missing angle. Big thing you need to know on this is whenever you're finding missing angles using trig ratios, use the inverse. And the inverse is the ones with the -1s. Okay, let me show you how you do this. This is really easy stuff. Okay, you'll get this pretty quick. Let me zoom in on this a little bit so you can be a little more clear. Perfect. Now, first of all, you need to know how to do how to enter inverse trig ratios in your calculator. It's pretty easy stuff. Let me show you. Okay, and I'm going to adjust this camera to be out here a little bit more. Hold on. Sorry, I'm messing around with stuff. Okay. In your calculator, guys, you have the three trig buttons. Sorry, that light's just not doing me well. Okay, I'll have to zoom in again in a second. You have your three trig ratio buttons: the sine, the cosine, and the tangent. If you look above them, you see this inverse sine, inverse cosine, inverse tangent. Look at your own calculator. If you don't have one, go grab one. Pause this and grab one. Okay, to get to these things, you do shift. So if I want to use the inverse sine, I would do shift sine. And it has that sign with the little -1. If I want to do inverse cosine, I do shift cosine. See how that little inverse cosine? If I want to use the inverse tangent, I do shift tangent. See that little -1 up there? That tells you using your shift functions, your inverse functions. Okay, so let me show you. Let me show you what we're going to do for a moment. Okay, so the very first thing you want to do is identify the angle that you're trying to find. So let me just recopy this triangle here for a moment. I've got my C, I've got my A, and I've got my B, and this is 15, this is 20. I'm going to do the same thing over here. Okay, C, A, and B. I've got 15. I've got 20. Okay, now, so if I'm going to find angle A, that means angle A is what I'm looking at. The very first thing you see is, see, I know two sides. I've got to identify what are those sides. Are they opposite, adjacent, hypotenuse? In this case, this 15 is opposite over here. So I'm going to put an O here. This is the adjacent leg because this is the hypotenuse. And notice that I don't know the hypotenuse. In other words, I don't care about it. Okay? These two trig ratios, these two sides help to identify which trig ratio to use. I know the opposite, I know the adjacent, so I'm going to look for a trig ratio that has opposite and adjacent in it. It can't be the sine because it has opposite but not adjacent. It can't be the cosine because it has adjacent but not opposite. It is the tangent. Okay? So I set up this equation, the tangent of the angle, and the angle is A. I don't know the angle. And it equals the opposite, that's 15, over the adjacent, that's 20. Great. Now, I'm ready to use my inverse trig ratio. So I'm going to go the inverse trig ratio, so tangent -1 of the 15 over 20. And when I enter that into a calculator, it will give me my missing angle. So I use these two sides to identify that I'm going to be using the tangent. I set this up, and then I'm going to take the inverse tangent of that ratio, and it will give me that angle. So now it's a calculator problem. So I'm going to go to my calculator, and I'm going to hit shift tangent of 15 over 20, and I hit equals, and there we go, 36.86, so 36.9. Okay, so this is 36.9 degrees. Cool. Okay. Got her? Now let's do the same thing for C. So, but something's going to change. I'm dealing with angle C, which means now this is my opposite side, and this is the adjacent side. But see, I'm still going to use the tangent because I still have the opposite and the adjacent. So I set up my equation, the tangent of angle C. See how I'm finding a different angle now? And that it's going to equal the opposite. Opposite of C is the 20 over the adjacent. Adjacent to C is 15. Great. Now, since I'm finding a missing angle, I'm going to use the inverse trig ratio. So inverse tangent of 20 over 15. And I type that in my calculator. I get the inverse tangent of 20 over 15 equals, and I get 53.1. Okay, now I can check my work because, see, if I add together the three angles of this triangle, the 90 degrees that I found that's right there at B, plus the 36.9, which is A, plus the 53.1, that should add up to 180. So I'm going to check it quick. 90 plus 36.9 plus the 53.1 gives me 180 degrees. And there it is. So that really is how you do things. Okay? Let me show you another example for a moment. Let's look at example 2. Okay? Now, I'm going to just work in a couple of different colors for a second. If I'm finding angle D, there's angle D. What do I know? That's opposite, adjacent, or hypotenuse. That's the hypotenuse, so I'm going to put a hypotenuse there. And this is right next to it. So this is adjacent because this is opposite. But see, I don't care about this side. So the only sides I care about is the adjacent hypotenuse. So adjacent hypotenuse, that leads me to the cosine. So I'm going to set this up. The cosine of the angle D is equal to the adjacent, that's 10, over the hypotenuse, that's 17. Now, since I'm finding a missing angle, I'm going to take the inverse cosine of that ratio, 10 over 17. And when I type that into a calculator, I'm typing in the inverse cosine, so shift cosine of that 10 over 17. 10 over 17 gives me 53.96. So I'll round that. That's just going to be rounded to 54 degrees. I know the instructions up here said to round it to the nearest hundredth. Let's just go tenth. Let's go one decimal place up there. Okay? And in your answers in your computer, in your homework today, put it to the nearest tenth. Okay? So D is 54 degrees. Cool. Now, let's do F. So if I'm going to do F, I'm just going to erase all this up here. There we go. And I'm doing F now. So, find angle F. So there's angle F. Now I label the sides. This is opposite, and this is my hypotenuse. So you see how since I changed from D to F, opposites and adjacents, they change a bit. So now I'm going to be looking at the sine of angle F. And I know sine because the sine is the opposite over the hypotenuse. It's the only trig ratio that has opposite and hypotenuse. So I set it up. The sine of my angle is equal to the opposite, which is 10, over the adjacent, which is 17. Okay, great. Since I'm finding a missing angle, I'm going to be taking the inverse sine of that 10 over 17. Okay, and the inverse sine of that 10 over 17, if I put that in my calculator, shift sine, there's the inverse sine of the 10 over the 17, I end up getting 36.03, so 36.0 degrees. Okay, and if I check it with the triangle sum theorem, I go 90 plus my 54 right there, plus the 36, and that is going to equal, sure enough, I can see that equals 180 degrees. Okay, if everything makes sense right now, great. You can go on with your homework and do your homework. Okay, but let me give you a caution. I've got a shortcut. So let me show you the shortcut with a couple of examples on the back. We're not going to do the whole back, but I want to do a couple. Okay? Here's my shortcut for a second. Check this out. If I'm going to do this, find the measures of angle A and angle C. Let's find angle A first. Okay. Angle A. So I circle that. I'm using that angle. That means this is the opposite side because that's across from it. Hypotenuse is there, but I don't care about the hypotenuse because I don't know it, right? That's the adjacent. Opposite and adjacent. Which trig ratio has opposite and adjacent in it? That's right, the tangent. So I know that the tangent of angle A is equal to the opposite side, which is 5, over the adjacent side, which is 13. So I'm going to take the inverse tangent. Sorry, I'm getting my hand in my way. Inverse tangent of that 5 over 13. So you set this up, and then since you're finding a missing angle, you're going to take the inverse tangent of that. That becomes a calculator problem. Shift tangent of 5 over 13. That gets you 21 degrees, 21.03. So A is 21 degrees. Now, guys, check this out. If I know that A is 21 degrees, and I know that's 90, these two have to add up to 90, right? Because 90 plus 90 makes 180. So all I have to do to find C, this angle right there, is I just have to go 90 minus the 21. And 90 minus 21, 90 minus 21, that gives me 69. So that's 21 degrees. That's 69 degrees. And there's my problem. See? Easy peasy. Check it out. Let's look at this one for a moment. I don't want to look at that one. Let's look at this one. Let's look at number 6. And that'll be the last one we do. Okay? So, number 6. Find angle A and angle C. I'm going to find angle A first. Okay? Angle A. So I need to... Oh, sorry. I'm doing that. I need to find angle A. Angle A, this is the hypotenuse. So first thing I do is I label these sides hypotenuse. That's opposite, but notice I don't know it. I don't care about it, so I'm not going to worry about it. This is the adjacent side. Now, once I have these, I have to think, which trig ratio do I use? Well, sine is opposite over hypotenuse. That doesn't work. Cosine is adjacent hypotenuse. That works because I've got adjacent hypotenuse. So I set it up, the cosine of that angle, angle A, is equal to the adjacent, which is, that's 6 over the hypotenuse, 10. Okay, great. Now, what do? Exactly, since I'm finding a missing angle, I do the inverse cosine of the 6 over 10. And that will give me my missing angle. So that's a calculator thing. So shift cosine, it was 6 over 10. And I put that in my calculator and I get 53.13, so 53.1 degrees. Cool. That is angle A, 53.1 degrees. Now to get C, I could do this whole trig ratio thing again like I did on the first page, but it's much easier just to go 90 minus that 53.1. And that's going to give me something. 90 minus 53.1 gives me 36.9. So 36.9 degrees. So that is angle C, 36.9 degrees. And that's it. That's what we're looking at. Your assignment today is on Canvas. It's also on paper. Go ahead and get that. Finish the assignment. Enter your answers in Canvas. And good luck, guys. Hopefully this helps. Bye-bye.